To begin, let's start by going over some key terms.
Thermal expansion is when matter changes in its shape, size, area, and volume in response to a temperature change. For example, when your water bottle freezes overnight and the plastic stretches out, that is an example of thermal expansion.
Thermodynamics is the change in volume or length due to changes in temperature. When cooling occurs, the material shrinks, and when it heats, the material will expand.
Now let's see thermal expansion through some experiments. For our first experiment, we'll be showing expansion and contraction through different temperatures of water. So the items I'll be using in this experiment is cold water, which is in the white bowl. It's just cold tap water, and I brought snow from outside that I'll just dump into there. Then in the clear bowl, I do have hot water, which I just boiled up. Then I have a empty Gatorade bottle, which I sealed the top with a balloon. Now, during the experiment, I will be placing this water bottle in different temperatures. So as you can see right now, I have it in the hot water and the balloon is expanding, so it's inflating. You can see it slowly growing, getting bigger. Then I'll move it to the cold water and you can see it easily contract and it gets smaller and it deflates. This occurs because of the air molecules that's trapped in the bottle. They are expanding and contracting due to the different temperatures of water, causing the balloon to deflate or inflate. So what happens if an amalgam restoration expands? In this demonstration, I do have a cardboard cutout of a prep tooth, and I'm blowing up a balloon to resemble an amalgam filling expanding, so it'll grow. So as you can see, as it expands, the tooth won't be able to take it anymore, so eventually starts to break and crack. Now what happens if an amalgam restoration contracts? Well, in this photo, taken by Dr. Carissa Gill, it shows there is microleakage. And so that means that there is a space between the tooth and the amalgam filling itself. And if this isn't cleaned properly, food can get trapped in there, which can cause decay. So as you can see in this next demonstration, the black balloon, which is the amalgam filling, is a lot smaller. That's what happens when amalgam contracts. And so I'm pouring green pellets to resemble food that can easily fall into that leakage space between the tooth and the amalgam filling. So now you must be wondering, is thermal expansion important to the dental industry?
Thermal expansion and contraction is very important for the dental industry regarding restorations, as they obviously do affect the teeth. The composite restorations expand with heat and contract with cold, but not as much as the amalgam restoration.
The process of a restoration, in this case amalgam, contracting when exposed to the cold and opening gaps between the margins of the restoration and the tooth, and then closing this gap as the restoration expands when it heats up again, is called percolation. Percolation of amalgam can eventually lead to marginal leakage, recurrent decay and discoloration, and hypersensitivity. Percolation may occur during everyday activities such as simply drinking a cup of hot coffee or eating something cold like ice cream. In regards to thermal expansion and contraction with amalgam, it is important to note that changes due to the cold is reversible, but changes due to the heat are usually not, because the expansion may cause damage such as fracturing the tooth itself.
Now we will be showing thermal expansion in a second experiment.
In this experiment, I will be using 2 big containers, one filled with hot water and the other with cold water, a jar with a straw poked through the lid, and colored water that will be in the jar. In this next demonstration, we are showing how, like gases, liquids expand and contract. First, we place the jar into the warm water, and we have to wait a moment for the water inside of the jar to heat up, and then we will see it rising a bit above the lid. and it's a little above right there. And back down. And again, you can see how it's raising just a little bit above that line of the lid right there. And now as we bring it over to the cold, you can see as it drops right back down, moving it back to the warm so that hopefully we can see it go up one more time. And this is showing that the water is expanding as it is getting warm, just like with the gases in the previous experiment with the balloon.
Okay, so by now we know a little bit about thermal expansion when it comes to the mouth and restorations, but I thought it'd be cool to kind of look at thermal expansion that can be seen in everyday life. For example, engine coolant is a really great example of thermal expansion. It's found inside a car's radiator. So if the radiator is topped off with coolant on, say, a cold day, then an increase in the temperature could make the coolant expand until it overflows. In the past, this produced a problem for a lot of car owners because car engines released the excess volume of the coolant onto the ground, and it just caused a spillage of kind of a toxic material. Another thing we see in everyday life, which I thought was interesting, was in jar lids. So I'm sure a lot of you have tried to open jars, and they're just very tough to open, and you need some big, strong man to open it for you. But if you don't know, a trick is if you cannot open a jar very well, you stick it under hot water and the jar can open. Well, this is another really great example of thermal expansion. Almost everyone has tried to do this, but you can't get the lid off. But then the water makes it give way. The reason for this is that the high temperature water causes the metal lid to expand. So it's easier to get it off the glass. So now that you've seen these examples, can you think of any more examples?